So we've seen how climate change could kill you through extreme weather events, through contaminated water, drought, water scarcity. So let's go to vector-borne diseases. So Dr. Jan had mentioned the increased risk of contracting diseases that are waterborne, infectious agents in water. So with vector-borne, what we're talking about here are microbes that cause disease that are transmitted through the bites of pretty much insects. So, for example, here in northeastern United States, one of the major diseases in terms of frequency is Lyme disease, and that's an example of a vector-borne disease because the way it's transmitted is through the bite of a tick, not an insect, but an arthropod. And so that's what we want to focus on now. As you might guess, again, drawing on the information in this website that focuses on the U.S., in a minute we'll expand to the world. When you look at vector-borne diseases, one of the things that you notice first and foremost, particularly Lyme disease, and again, why Lyme disease gets so much attention is because of the high frequency, particularly in northeast United States, but in other places, of it in the tick population and your chances of contracting it. So here's a nice visual showing the increased frequency of Lyme disease cases in the northeast United States from 2001 to 2014, and in some of the Mideastern states as well. So that's definitely been on the rise. And, you know, when you go look at predictions from this, key findings with this, I'll get to that. No surprise that the role climate change plays with vector-borne diseases is changing the distributions of vectors, more specifically increasing the range, particularly expansion of ranges into more northern latitudes, okay, from more southern latitudes, meaning more closer to the equator. The expansion and activity period, for example, of the deer tick or black-legged tick, same species that is the principal vector of Lyme disease. So expectations that those will be active during a greater portion of the year around here. Okay, they'll be active earlier as our springs keep coming earlier and our falls happening later, or the onset of cold weather. And, you know, their expansion into ranges, areas that they didn't used to be. So this key finding focuses on Lyme disease and ticks particularly. Obviously the risk of human exposure. But we also have another major vector of many diseases worldwide, and even here in the United States, are mosquitoes. So a lot of concern has to do with, and the questions that are asked is, what kind of influence might climate change have, or is already having, on mosquito-borne illnesses? And as you might predict or guess, that with global warming, mosquitoes, the ranges of many species of mosquitoes are expected to expand, and is even happening now. And that's actually a point I want to bring up. The other thing, and that this website does a good job of doing as well, is distinguishing and making the point between of what we expect to happen and what we can predict based on, you know, solid scientific evidence and models. We could say with whatever degree of certainty that we expect this to happen, versus that's still different than what is happening now, or is any of this happening already? And that is an important distinction, and one that some people bring up. So it's important to point out, like this website does, showing that many of these events and impacts are happening already. Evidence and data is accumulating. We're not just talking about anymore what's going to happen in the future. It's already happening now. And they're showing that with these expansions of ranges and many vectors. This is the one I want to show you. Yeah. Here's an article that just came out that summarizes that. I like the title of it. Again, obviously, this is a secondary news source, but it's reporting on a scientific journal article, Climate Change Bites. The fact that as temperatures continue to increase, average global surface temperatures, you're going to see expansion in ranges of mosquitoes and ticks, and thus to the diseases they transmit, and particularly, you know, probably the best part of this article to focus on at the beginning is that they're now seeing these agents that cause the diseases showing up in areas that they haven't been previously reported. And that definitely coincides with their vectors now being present in areas that they weren't before, which is what you would expect. And it's not just expansion of ranges into more northern latitudes away from the equator, both in the northern hemisphere and southern hemisphere, but also altitudinally. And this is something that biologists are seeing already, is how you have, as you go up in altitude, that you have the weather warming in that way too. So in certain parts of the world, they're already seeing that. So let's see, where do they have it? In certain parts of Africa, highlands of Africa and South America, they're finding your risk of contracting mosquito-borne diseases is greater than it used to be, as they're expanding the ranges altitudinally as well. When we go back to mosquito-borne diseases, mosquitoes transmit just a wide number of diseases, but perhaps on a global basis, the most important definitely is malaria. And this map is showing the expected change or expansion of malaria. What's shown in gold or yellow is the current distribution of the agent that causes malaria, and what's shown in red is what is expected by 2050. And you can see there are many areas further away from the equator and large geographic areas, including southern United States. They're expected to have an increased risk of contracting malaria from expansion of the mosquito vectors. Another major disease worldwide is dengue fever. And this graph showing it a little bit differently, and again, this one just focuses on the United States, that when you look at changes in the current temperature, so you have what's shown, you compare the height of these different bars. So you have the yellow bars, current conditions. So the orange one is if there's an increase in average global surface temperature of 2 degrees Celsius, and then the red would be 4 degrees of Celsius. You can obviously see a significant increase in the way they're quantifying is number of weeks of potential dengue transmission under those scenarios. And I think, to me, what's most interesting is, as you might expect, that's fairly high and increasing in the southern area of North America and the southern United States, but northern cities in the United States and North America, you're going to be seeing that as well. When you look at it on a global basis, just to show the impact that dengue has, this is a major serious disease on a global basis. You can see that what they're showing just in the decade from 2001 to 2010, that the number of episodes, people experiencing dengue fever has increased significantly, and as well as the costs, economic costs associated with dealing with that.